Jeff here. Got this little project I'm working on, and it'll reveal itself as we move along, but it's something that's been long in the coming. It goes back to an interest I've had since I was 11 years of age. So I'm just show you some of the steps I'm taking right now and explain it more fully to you as a course of ongoing revelation. That's always fun. Anyway, what I did is I went out and I collected some cardboard. Now the cardboard has to be shaped, because not all cardboard has the same shape, and it's not necessarily the shape you want or the dimensions. The dimensions I want in my cardboard are 4 feet across and 8 feet long. Well, some of you who have worked with construction materials know that that's the standard dimensions of a piece of plywood. So this project has something to do with something that's the shape of plywood. Now, I won't use plywood in the product because I want something that's a little more attractive than plywood. It'll probably be, right now I'm thinking T111, which is a kind of board that has crenellations and it's often used as a more artistic virtue to it than flat plywood. So what I have to do to prepare this, however, is I do want to make a 1:12 ratio between 1 inch is 1 foot. So it's got to be 4 inches across and 8 inches long. Right now I'm in the process of rendering this piece of cardboard to the same dimensions. So all I do is I mark a line across it at the appropriate dimensions, I get the scissors out. I'm not being especially careful because this isn't necessarily, this is just a mock-up, it's a model of what could be. And then I compare the two pieces, and they should be roughly the same dimensions, and they're not. This one's a little bit longer, so what the heck? I think I will remove maybe a couple millimeters off the bottom, so they're the same size. Now what I have is 2 pieces of plywood dimension cardboard. And I can do things with it. I can make letters out of it. What letter is that, kids? Or that. What is that? That's like a 10, right? All right? I could do something like this. So this could be a floor and this could be a wall, for instance. I can do lots of stuff with it. I can make it 2 walls. 2 walls all by itself isn't very helpful. What I want to do with it is I want to get lots of these pieces and then I want to do something valuable with it. And I already have something in mind. So let's consider one of these to be like a wall for the time being. But if I was to build a structure, I'd need at least 4 walls and I'd need a roof. Well, how might I do a roof? Well, I've already decided in this project that my roof is going to be this shape doubled over. That's a long, tall triangle. And the length of this triangle is 6 inches. And the base should be 2 inches. All right, something like 2 inches. So I take one piece of the cardboard, I lay this little pattern out on it, I center up the tip, 2 inches. Remember, this has already been dimensioned and cut, and I use it as a pattern to draw a line from here to there, and then I flip it over, and I do the same thing from here to there. And then, of course, my next step is get the scissors out. And I cut it into my little pie-shaped wedge. Not the most perfect cut. If I were actually doing this as part of a construction project, I would probably use a table saw. So everything, and I would measure thrice, make sure all the dimensions are right, lay it out perfectly, and I would get a table saw, and I would feed the T111 or plywood, whatever's being used, through to get a perfect edge on each and every one of these. Keep in mind that working with power tools is not something I have a lot of experience with, but I have a basic idea, and I have cut wooden things in the past and done something in construction. There are people who are far better at it than I. Anyway, now I have this triangle thing, and I have this wall-y thing. Now, If I put the wall like this, the triangle doesn't do me much good. It doesn't expand it. So anybody using a little bit of imagination would figure out this goes up here. Boy, that looks like the peak of a roof of a house, doesn't it? Except I won't use it that way. I'll do it more like this. Okay, now let me give you an idea how I would use this material once it's dimensional. This is the design. And if Vanessa comes over here and looks from the top, you will see that it is a 6-sided structure like a hexagon, right? If you go back to the side, you can see that there's going to be what I call 6 facets to this. Now, that's a structure, right? Well, let me just show you quickly how this works. You take that little triangle there, and you take this little rectangle here, and then you made them together, and you got a wall and a roof. Now, can't get any access, there's no doors. Well, one option for the doors is that each of this facet can fold down, and now you have like a ramp, assuming this is ground level right here. Okay, now the big reveal. If you look inside, you'll see a little mock-up of something. What does that look like, Vanessa?
Telescope.
Telescope. So, although a structure like this could be used for lots of purposes, my motivation for developing this structure is to create an observatory. Now, why might I need an observatory? Well, I need an observatory because, frankly, if I have to cart a bunch of equipment out of the backyard on a good night to observe, I ain't going to do it. I did that 20 years ago. 20 years ago, I was really deep into amateur astronomy. I put up a very excellent website in cooperation with other amateur astronomers called astro.geekjoy.com. Several thousand people visited it every day. And every night for about 200 nights out of 360, whenever the weather was good, I hauled my equipment up to somewhere and I did some night sky observing and published reports on the web. Did sketches of astronomical dark sky studies and planets. Did a lot of communications with other amateur astronomers. Some submitted articles for the website. You can still find it. It's no longer on a server that I own, but it's now been archived on Google. So you can go to Google Archives and you can look up astro.geekjoy.com and you can find at least 100 articles covering everything from equipment through night sky observing, star parties, and everything else. It was a very successful site, but it demanded an awful lot of attention, and I have a lot of interest, as you may know from our Golden Phoenix published channel. There's mostly music is dominating my interests right now, among other things, but mostly music. Anyway, why would I need an observatory? Because, boy, there are times where you step out at night in the backyard and you say, oh my God, what a magnificent sky and universe. And what you'd like to do under those circumstances, you'd like to go outside and you'd like to open a door and you'd like to step inside, drop in an eyepiece, and begin observing. And that's what this is designed to do. Not only is this observatory designed to be in your backyard on a semi-permanent basis, but when such an observatory is done, it will be completely disassemblable and stackable on a small trailer. And you could take it anywhere you want and assemble it. And you could park your mount and telescope inside of it for a glorious day, night after night in the summertime, feeling that your telescope is perfectly protected from the elements. Now, so this observatory is not only meant to be constructible by anybody with a reasonable amount of skills out of commonly available materials, it will also be portable. Now, how can it be portable? Well, one thing is, you got to be able to take it apart. To be portable, this thing can't be made out of nails and hammer and nail construction. It would have to be made out of hinged construction. And there's another reason why it needs to be made out of hinged construction. Because you would need to be able to open any of these 6 facets in order to observe any part of the sky you're interested in. The other virtue of having an observatory is, unfortunately, even in our small town of John Day, Oregon, there's lights. Neighbors turn on lights, street lights, even though they're astronomy friendly, they all distract from the experience of the night sky. So what you want is the capacity to screen out light that's extraneous to your observing. So what you want to be able to do is quickly drop whatever facet you want and observe the part of the sky you want to see without light coming in at another angle and hitting your retina and screwing up your dark adaptation of your eyes. So, one thing, the first thing you want about this observatory is you want a place to store at least your mount. Now, you may not leave your scope out there all the time, but you want that heavy mount. And we have a heavy mount here. We have a Losmandy Gemini 2, and it is too massive to ever move except in pieces. So the mount could stay out in the observatory, and the telescope you can hang carrying about. Now, so one of the things about this is you want to make it portable, which means everything has to be wing nut screw or hinge construction. Look how I have it hinged here. Well, that may not be the optimal way to hinge it. Think about if you had hinges here and here and here and it swung the other way. Now, another thing you got to be aware of is that when you set up a telescope, you want to have a good north view. So you need to be able to at least drop the roof down and have the telescope high enough so you can see Polaris, which is the North Star, in order to be able to line the mount up so that it can properly track, and also, like the Losmandy, be able to find anything in the night sky by simply telling the mount what you want to see. It's called go to or push to. And you can find anything that's been accurately documented as to right ascension and declination, or what is known as sky position, visible from your locale. There are a variety of ancillary problems you will have if you build an observatory of any type. One problem you have is you don't want condensation to build up inside, so you can imagine there has to be a solution for having fresh air for flow and circulate inside the observatory. Another is you don't want any rain getting in. Now when you look at this construction, look at the gaps. You can see gaps in this cardboard. Well, in the real world there'll be gaps, and you're going to have to find a solution to the gapping problem on the roof. You may also notice that this particular roof is at a steep angle. Well, the virtue of a steep angle is water is going to run off very quickly and not tend to get inside the observatory. The problem with it is this is very tall. Remember, I said 1 inch to 12. Look at this. This observatory will be almost 14 feet tall. And the virtue of it, it's 8 feet across, which means it gives you a good working space to slew your telescope around. That may be a bit too much. For one thing is you're going to have to find a way to be able to disconnect this baby and drop this to get in. So you may not want as steep a roof on your observatory. But there's a other reason for a steep roof on this observatory. This is meant to be scalable. Think about this. You can build as many of these facets as you want. You could have an octagon instead of a hexagon. That means 8 facets, 8 sides. 8 sides would give you at least a 9-foot interior diameter workspace. And if you have a Dobsonian telescope, you need a lot of space to spin that scope around. Now, if you have an SCT or an MCT, which are really short-bodied, long focal length telescopes with wide apertures, man, you could probably get by with a pentagon instead of a hexagon. So what we want to build into this design is the ability to extend the roof to different lengths depending upon how many facets you build. So here's the point. Imagine you can build as many of these facets as you want. You could make a triangle-shaped observatory if you want. Well, you barely fit in it. You can make a square. You can make a pentagon. You can make a hexagon. You can make an octagon. You can make as large an observatory as you can personally handle. And all you have to do is build one of these facets at a time and then hook them up to the others and find a way to seal the gaps. Now, sealing the gaps is going to probably come down to something like rubber strips between these. Haven't solved that problem yet. Don't know enough about available materials, but I know somebody who does. That'd be our friend Lee Snyder, and Lee will jump in and he will come up with some of these solutions in consultation in the future. Okay, so this observatory is probably a little too big. If you look at this telescope inside here, it's 5 feet off the ground with a mount. which is roughly about the size of the Losmandy, although it might be a little higher. And the telescope, if you measured it, would be 4 inches across, which is 48 inches. But the telescope that we're going to plan for this observatory is a sky watcher, which is probably more like 5 feet. But the beauty of it is, we got way too much clearance in here. So probably for our final observatory project for here, we're going to take 2 inches off this. So that means that this area right here is the top of the observatory that's straight up the wall on a facet, will be 6 feet high, but we could probably go 5.5 feet. Meanwhile, I don't have to make the roof, the ceiling here, 6 inches. It could be 5 feet or maybe 4.5 feet, but it would have a less of an angle to it, but it'd be more accessible to reach up and grab a handle and pull down. So we may, in the long run, redimension this, but I wanted to build a little bit of a model with lots of extensibility. So the idea will be, in the final analysis, this may not actually be the dimensions of the project, but it will all start with 4x8 construction. And the idea is to minimize the amount of lost material. Because look, you know, you're going to cut a plywood, you're going to have this material left. Well, one of the beauties of it is you can cut here, and you can cut here, and then you can fuse these two sides together to make another one of these, so you can save some material there. You can imagine that this is not the end of this project. This is just the conceptual level. There will be steps all along the way that relate to final design, dealing with humidity, condensation, and drippage into the observatory. Plus, there could be a problem of routing power to it because most mounts need some DC. So that could be AC power into an inverter, or it could just be a battery source power for portable operation. There will also be some issues of varmints. You know, if creatures get inside, they love chewing on stuff. So you're going to have to, in the final analysis, it's going to have to be immune from like insect and rat incursions. It's going to have to be dry inside. You can also even have silly problems like the design is not good because your body's inside heating up the inside of the observatory and the warm air is leaking out, and when it leaks out it can disturb your observing. From a practical point of view, you're also going to have more and more of a limited amount of sky visible as you go up through the roof. Most astronomers will never look straight up anyway, so you can forget this. So obviously, the lower the observatory is, the wider this is in terms of apparent size, the more of the sky you'll be able to see with the telescope without actually removing a facet. So all of these things are going to have to be worked out. But the beauty is, start with a concept and then see what you can do with it. And the concept is, have an observatory made inexpensively in your backyard with at least your mount in it, so you can go out whenever you want, mount your telescope up and observe on a beautiful night, and all those other nights, sit inside, listen to music, throw darts, shoot pool, play ping pong, watch Netflix, streaming services, whatever. But when the sky is sparkling and you're inspired, there will be no barriers to entry. You will just step out, mount that scope, and start having a look at the magnificence of the night sky, which is the one thing that everybody in the same hemisphere, northern or southern, can share. We can all look at the same things, and maybe even together. And once we see the scale of the universe, maybe things like pandemics, maybe not so much global warming, that concerns me, will no longer loom as large in our psyches, and we can begin to embrace whatever of life we happen to have at this time and come to truly appreciate everyone and everything around us. Anyway, this is part one. We'll move on from here. The JD, what we call the JD Backyard Observatory Project. Thank you for watching.